So hello guys, today we are going to solve a Leetcode question that goes by the name apply operations to make string empty. What does the question say? Apply operations to make the string empty. Question number is 3039. Okay, medium level question. So we'll first start by reading the problem statement. What does the problem statement says? Okay, so the problem statement says as you are given a string s. Okay, you have to make a string empty. So basically, it is quite basic that you will be given a string. Okay. You are given a string is consider performing the following operation until C becomes empty. Consider performing the following operation until C becomes empty. So we have to perform these operations that are listed below this line till S becomes empty, till the string becomes empty. Okay, what is the operation do we have to perform? For every alphabet character from A to Z, remove the first occurrence of that character in S if it exists. Okay, so what we have to do is from the string that we are given, we have to remove the first occurrence of each character from A to Z. Like we'll start by traversing from A and go till Z. And if that particular character exists in my string, then we have to remove the first occurrence of it. Suppose I have the string as ABC. I'll start by going from A to B to C to D to E to F. Okay, I start by traversing till it goes to Z. Till it goes to Z. What when I come to A, I find it that it is in the string. Okay, so I'll remove it. I'll remove it. I'll move forward. I'll go to B, and what I see is it is in the string. Okay, so I'll remove the first occurrence of it. Okay, if the string has two B's, so I'll remove the first occurrence of it. Okay, I'll go to C. I'll go to C. I'll remove the first occurrence of C. Okay, and I'll traverse till Z. As you can see, there is no more occurrence that appears after C in the string. Okay, so I'll traverse again from the starting. I'll traverse from A. I'll found nothing in the string. I'll traverse to B. So this is my point. I'll have to remove this also. Okay, so this is the first occurrence. After this, I'm not gonna find any character in the string. Okay, because now the string is empty. So this is what we have to do. Okay, so now we will read the question fully. For example, let initially a string is equal to AAB CBB CA. Okay, AAB CBB CA. Okay, we do the following operations. Remove the underlined characters. Okay, so in the first pass, we'll start from traversing A to Z. Okay, so we'll first traverse by A. We'll first go by A. Okay, when we are at A, we'll remove it. So when we will remove it, A B C B B C A B C B B C A. Okay, I'll traverse in every pass from A to Z. Okay, so in every pass I'll traverse from A to Z. So when I'll traverse first from A to Z, okay, I'll first check for A. I'll find the first occurrence of A. I found the first occurrence. I'll circle it. Okay, I'll circle it. I'll go to B. As I found the first occurrence, I'll have to break through. I have to break it. I have to break the loop because we have to just remove the first occurrence of that character. Okay, I come to B. Okay, I check the whole string for the first occurrence of B. I go from here to here. Here I found the first occurrence. I encircle it and break the loop. Okay, I'll go to C. See, I found the first occurrence. I come from here. I found the first occurrence. I'll circle it. Okay. So now if I travel from D to Z, I'll not find any occurrence of the character because as you can see from D to Z, any character is not present in the string. Okay. So for this pass, if I remove all the circled characters, then my string becomes A, B, B, C, A. A, B, B, C, A. Okay. Now that was the first pass. Now I'll traverse from A to Z again. Okay, I'll go to A. I'll go to A. I'll find the first occurrence of A in the string. First occurrence of A. I start and I find the first occurrence of A. Okay. Now I'll go to B. I'll traverse the string and I'll find the first occurrence of B. I'll break through. I'll break the loop. I'll go to C. Okay. I traverse the string. I found the first occurrence of C. I'll break it. Okay. Now from D to Z, we are not going to find any character that exists in the string. Okay. So this was my second pass. This was my second pass. And what is the string now after the second pass? What my string has become? B and A. Okay. I'll again traverse from A to Z. I'll again traverse from A to Z. So A, when I go to A, when I go to A, I'll traverse it. I find the first occurrence of A. I'll remove it. Okay. I go to B. I find the first occurrence of B. I remove it. Okay. So after the third pass, what our string would be empty. Where our string would be empty. There would be no character in the string. Okay. So this is how the question wants us to do. What the question wants us to do. What we have to return is return the value of the string s before applying the last operation. Return the value of string s right before applying the last operation. Okay, that means before applying the last operation, before applying the third pass, I'll have to return the string. I'll have to return the string. Yani I have to return this BA. I don't have to do the third pass because this is my last pass. This is my last pass. And after this, my string would become empty. After this, my string would become empty. Okay, so this I have to return. This string I have to return. Okay, the first, so how do we do this? How do we do this? The first solution was very basic, very basic. We just travel the string. Suppose this is the string. Okay, this is the string. We traverse from A to Z in every pass, and when we find the first occurrence of that character, when we find the first occurrence, we just simply remove it. We just simply mark it or something, and we can again form a new string on every pass. We can form a new string on every pass, removing all the characters that were removed. Okay, we can do this for all. So what we can do is for one pass there would be 26 iterations. 26 iterations, as there are 26 alphabets, as there are 26 alphabets. So it will check from A to Z all the occurrences, and for every character it will check the whole string. It will check the whole string. Suppose my A is lying first here and the whole string doesn't contain any A. Okay, so it will check the whole string for this case. So time complexity becomes 26 into n. 26 into n. Basically not, okay, 26 into n. Okay, and this is till, this is till my string becomes empty. Till my string becomes empty. So till my string becomes empty, that means that 26 into n are the operations, and this can be applied into k times, k times are those in which my string becomes empty. In which my string becomes empty. Oh, so maybe in the last case, maybe if every character is different, like maybe it can happen, it can also go to n. So it can also go to n. So my time complexity becomes 26n square. That is not a good time complexity. That is not a good time complexity. I need to optimize this. I need to optimize this. So how would I optimize this? Optimal approach. Okay, if I try the first test case, I'll take the first test case AABC, okay, and okay, this is my string. Okay, and as you can see, we are given that we can perform the following operation. It is given that we can perform the following operation until s becomes empty. So there is no constraint. There is no constraint like that, that we have a particular amount of moves, the particular amount of moves are not given, particular amount of moves are not specified. Okay, So any number of operations can be performed. Any number of operations can be performed. And if any number of operations can be performed, and we are traversing from A to Z, we are traversing from A to Z. Basically in one pass, I'll remove all the characters, all the first occurrences in the string, all the first occurrences of that character in the string. Okay, like for A I'll remove this, for B I'll remove this, I'll be for C I'll remove this. Okay, for first pass. Okay, but for second pass, third pass, fourth pass, and so on, fourth pass and so on, I'll eventually remove all the elements. I'll eventually remove all the elements because I have no constraint over how many times I can remove an element. How many times I have to remove an element? A B C B B C A. A B C B B C A. Okay, I have no constraint over how many times I can remove an element. So if we observe carefully, we have to remove from the range A to Z, that means covering all the characters, and we can remove it any number of times. Remove it any number of times. Any number of times. But bhaiya, it is given now, we have to remove the first occurrence. Array C, you have to remove the first occurrence. But if you see overall, as this becomes deleted, this becomes my first occurrence. As this becomes deleted, this becomes deleted, this becomes deleted, all the string is empty. This also becomes my first occurrence. So there is no such thing as first occurrence in this case. Why? Why? Because at the last my string is gonna be empty. At last my string is gonna be empty. At last my string is gonna be empty. So if my string is gonna be empty, for sure, it is given that string is gonna be empty. So it doesn't matter. It doesn't matter from where you are removing. From where you are removing. From where you are removing. Okay, from where you are removing, it means like all the strings would be deleted. All the first occurrences would be deleted. Like it will matter, but like you don't have to, for each test case you don't have to check whether to remove this string or this string, this string, this string, this string, this string. Okay, so A B C B B C A. Okay, A B C B B C A. So what we can infer from this is, if we have any number of chances to remove, and we can remove every first occurrence of all the elements. So it means that, and we have to return the very last occurrence. Like there would be a time where one pass would remove all the elements. Like if this is the case, if this is the case at last, one pass from traversing to one, from 1 to Z, would remove all of these elements. So I'll have to return this. I'll have to return ABC. Okay, I'll have to return ABC. So what I can simply infer from this is, A B C B B C A. What I can simply say is, what if, like, if you are throwing something, like consider like this case, if you have 3 3 3 and 4, 3 3 3 and 4, like eight toffees you have 3. No, this is first child, this is second child, this is third child, and this is fourth child. Okay, I say to every child that in 1 minute you can eat only one toffee. Okay, so, and you have to eat till your toffees become exhausted. So what they will do in the first case is, they'll eat one toffee. Okay, they'll eat one toffees. So this 3 becomes 2, this 3 becomes 2, this 3 becomes 2, this 4 becomes 3. Okay, this is in the first minute. Okay, let us talk about the second minute. As soon as the second minute is there, it becomes 2 2 2 3. Okay, 2 2 2 3. We have to calculate. We have to calculate what, which child will have the most number of remaining toffees at last. Most number of remaining toffees at last. Okay, they have to eat one toffee in 1 minute. Okay, so in the second minute, this 2 would be reduced to 1, this 2 would be reduced to 1, this 2 would be reduced to 1, and this 3 would be reduced to 2. In the third minute, in the third minute, this 1, this 1, this 1, and this 2. This 1 will become 0, this 1 will become 0, this 1 will become 0, and this 2 will become 1. So there comes a point that all of these toffees, all the first, second, third children have their toffees exhausted, but the fourth child still has toffees, still has one toffee, still has one toffee, still has one toffee. What I want to infer from this is, what I want you to gain from this is, basically the person, the children, the child that will be having, the child that will be having the maximum number of toffees at initial, maximum number of toffees initially, that will have the maximum number of toffees initially, will have the most number of toffees remaining, most number of toffees remaining at last, most number of toffees remaining at last. Okay, suppose one child has 3 1 3 1 3 and 1 4. Okay, 3 3 3 4. Okay, so if I tell them to eat one toffee in 1 minute, so the fourth child, it has the maximum number of toffees, and when all of these child toffees will be exhausted, he would be the one left that has one toffee. Okay, so if we see that maximum, the child that has, the child has that has maximum toffees, the child that has maximum toffees at initially would be the one that will have toffees at last, that will have toffees at last, that will have toffees at last remaining, that will have toffees at last remaining. Okay, if I apply the same thing, to my test case, a b c b b c a. Okay, if I say from a to z, the characters that would be having, suppose these characters are my children, a b c. Okay, the characters that would be having the maximum frequency, like a is having a frequency of 3, b is having a frequency of 3, and c is having a frequency of 2. So the characters that would be having the maximum frequency initially would be having the maximum frequency when every other frequencies are 0, because you are given with the maximum frequency at the initial state. Okay, so when every other element doesn't have any frequency, you will be the one that will have the maximum frequency, because if I subtract 1 from each, then 1 from each, so this would become 1 and this would become 1, c would become 0. So this would be the case a and b, this would be the case a and b. In this case my a and b would only remain, because after this if after this I remove, that is like my third pass, that is like my last pass, because this would also be exhausted. So I have to return the step that was just beyond the last step, that was just below the last step. Like I have to return the second last step, staying at second last step. So if I try to summarize what I just said, the characters having maximum frequency, the characters having maximum frequency initially, the characters having maximum frequency initially will be the ones that will remain till last, that will remain till last. Suppose you are playing a game, you are playing a game, and you have 5 players, one whose health is 10%, one whose health is 20%, one whose health is 33%, and one whose health is 40% and 40%. Okay, so what I can infer from this is, what are the first elements that are going to be gone, what are the first characters that are going to die. So this character would die first, then this, then this. So what are the characters that would remain till last? These are the characters that would remain till last, these are the players that would remain till last. So the fourth and the fifth player would remain till last, and after some time they will also exhaust. So this becomes my second last state, this becomes my second last state that I have to return, Okay, if I take this test case, A B C C B B A, okay, and if I map their frequencies, okay, so I map their frequency of A 1 2 3 4. A is 4 times, A occurs 4 times, B occurs 3 times, and C occurs 2 times. So what is the maximum frequency here? What player has the maximum strength? My 4 A4 has the maximum strength. A4 has the maximum strength. So this would be the player that will remain at last. This would be the player that will remain at last. Okay. This would be the player that will remain at last. Okay, and all the other players would be exhausted. All the other players would be exhausted. This will become 0 and this will become 0. So this would be the player, A would be the one that will last till end. Okay, that will last till end. Okay, so what if two characters have the same frequency, like AA BB CC BB AA? Okay, so here A has a frequency of 4, B has a frequency of 4, C has a frequency of 2. Okay, so what are my strongest players? A and B are my strongest players, as they have the highest strength, as they have the highest frequency. Okay, so these are my strongest players. And what is my weak player? What are my weak players? C. This C would be exhausted at last. And what I'll remain with? I'll remain with A and B. So can I return this A and B as it is? Can I just concatenate them in a string A and B? And can I return them as it is? No. Return them as it is? No. Why no? Because there is one more golden condition given. What is the golden condition? That I have to remove the elements from the starting. So the elements that would be at the last, will be the first occurrence from the end. Because suppose it has an occurrence of 4. So in the first test case, this would be gone, and this would be gone. In the second pass, this would be gone, and this would be gone. In the third pass, this would be gone, So what would remain? At last is the first occurrence from the last, of the string. Okay. If I see the test case that is given on Leetcode, AA BC BBCA, and if I try to map their strengths or their frequencies, A occurs 3 times, B occurs 3 times, and C occurs 2 times. Okay, so what are my strongest players? I have to identify my strongest players. A is my strongest player, A and B are my strongest players, and C is not my strongest player. Okay, so this will be eliminated. A and B would remain. Now this I know that A and B would remain. So can I return them as it is? No. Can I return this as it is? No. I have to traverse the string from the back. I have to traverse the string from the back, and I have to map the first. I have to map the first occurrence. I have to map the first occurrence of these elements in an order, because it is ordered. It is given that it is ordered. Okay. So this will be pushed at first in my string that is to be returned. First A pushes, then as I go back, I'll just have this B, I'll just have this B at last. Okay, just have this B. I'll simply then push my B. I'll simply then push my B. Okay, I'll simply then push my B. As I am given a statement that I have to remove the characters from the starting, so I'll see my answer from the end, because in the end only the last characters would be remaining in the string. Okay, so still, if I try that, if I say you that is this the right answer, is this the right answer? No, it is still not the right answer, because if we see AB, this is not the one. These are not the ABs to be returned, because the order is reversed. If you can see, the order is reversed. So what I'll do is I'll simply reverse this string at last. I'll simply reverse this string at last. So my answer is reversed. So what it would become? What it would become is AB becomes BA. That is in the given order. That is in the given order in the string. Okay, it is following the order. So now this BA can be returned. Okay, if I try to summarize what I said is, by considering this example, okay, A has a frequency is 2, C has 2, B has 1. Okay, so what are my strong players? A and C are my strong players. This would remain at last. Okay, I have to identify the maximum frequency, and I have to identify what are all the elements that have the maximum frequency. How I identify that? I'll simply traverse the string. From the ending. Why from the ending? Because what was my condition that was given? I have to remove the elements from the starting. So I'll just simply traverse the string from the end, and I'll get those elements that remain at last. Okay, so A and C has a frequency of 2. That is my maximum frequency for now. Okay, I traverse the string from the last. Okay, and what I see is, does C has a maximum frequency of 2? Yes, C has a maximum frequency of 2. I simply push it to my answer. Okay, I'll go forward. C, again comes C, but this C is removed. Why? Because one C will be removed. There would be only one occurrence that would be remaining. Okay, is my B removed? Yes, my B is removed. He's a weak player. Okay, A is also removed. Okay, so this A would be the one that would be remaining. Okay, so I'll simply push this. So I have gotten my string. But is this string the right answer? No, because my order is reversed. So I'll just reverse the answer string. And what I get is, I reverse CA, and what I get is AC. Okay, and this is my answer. If I try to code this, what I'll do is, I'll simply declare an unordered map of characters and ints. Okay, I'll store all the characters occurrences in my map. I'll store all the occurrences. String answer is my answer that I'm going to store. But first I have mapped it to the elements, its frequency. Now I know that what character strength are present. Okay, so I have to identify the characters that are having the maximum strength, and first I have to identify the maximum strength that can be there. What are the strongest players? So I'll just declare a map. I'll just declare a maximum element that would be mapped to the minimum value, and I'll update it. I'll just simply try to allot it to the maximum strength that could be present. Maximum strength that could be present. Okay, maximum strength could be present. So now I know the maximum strength. Now I know the maximum strength. Okay. Now what I'll do is, as I said, that the characters would be removed from the starting. So I'll traverse it from the back. I'll traverse the string from my back. Instead of traversing from the back, I'll just simply reverse the string. I'll just simply reverse the string, and I'll simply reverse the string, and I'll traverse it from the start. Okay, because like in this case, ABC becomes CBA. Okay, I'll simply traverse this, and if if my character has a frequency that is equal to the maximum frequency, if my player is the strongest player that is even in the game, so I'll just simply push it to my answer. I'll simply push it to my answer. Okay, but what if see, if this is my test case, A B B A, okay, C A, okay, A is 3, B is 2, and C is 1. So this would be removed at start. This would be also removed, and this would be the one that will be remaining. Okay. So if I come across this, so I'll simply push it to my answer. But if I encounter any more A's, are they still the maximum element? No, that's not the strongest now, because these A are removed. These A are already removed. From this 3, there would only be one remaining. There would be only one remaining, because all the overlapping ones would be removed. The maximum one, the maximum element, the maximum player only will have the difference of the strength. Because if 4 players are there, one has 10%, 20%, 30%, and 40%, and if all the 4 are attacked, so this 10 would become 0, this 20 would become 0, this 30 would become 0, and this 40, as this 30 is the maximum that is reduced, so my 40 would become 10. Okay, this would also be reduced by 30%. Okay, so as I find the element that has a maximum frequency, I'll just simply reduce its frequency. Why? So that it is not added again. Okay, and now, do I get my answer? Thus my solution is finished? No, I get the answer. I get a string, but if I try to run it, I just simply get the reversed version of it. My answer is BA in this case, as you can see, but I am getting AB because I traversed from the last, and my order is reversed. So what I'll do is, I'll just simply reverse the string. And now I'll try to submit it. Run. Okay. So successfully submitted. So this was the solution. If I try to summarize what I did, I just stored the frequencies, I just identified my character strength, and I stored their strengths in a map. Okay, I identified the player with the maximum strength. And the maximum strength of the player would be the only one that would be remaining at last. Okay, so I'll just push the maximum into my string. But what I get as a string is, I get the string as a reversed order element. So I'll just reverse my string. I'll just reverse my final string, and what I get is as the answer. Okay. If I try to analyze the time complexity, O of n is for storing the elements in the map, Second is for mapping the maximum frequency, okay. And third is the one that is for identifying my maximum elements and pushing them to the map, pushing them to the string. So my time complexity somewhere is O of 3n and reversing also, so 4n. So we are neglecting the 4, and O of n is my time complexity. And what is my space complexity? I am using a string to return, but that string would not be counted. My map would be counted, and in the worst case, what is the map size? It can be O of n. So my space complexity is O of n. Space complexity. So my space complexity is O of n, and what is my time complexity? Time complexity is also O of n. Okay. So I have reduced the solution. I have reduced the solution from 26n square to O of n. 26n square to O of n, and space complexity to O of n. Okay. So this was the solution. This was the solution of this question. If you have any doubts regarding this question, you can just ping it down in the comment section. And if you do like the solution, just share, subscribe, and like the video. Okay, I'll come up with more solutions soon. Okay, so thank you so much. Enjoy your day. Bye bye.